So we've been talking about fields and charges, and this question's kind of cool because it asks you to compare the electric field at two different distances from a point charge. You've got a charge, and you don't know what it is yet. That's your unknown down here. You know, however, what the electric field is at a distance r1, which is 0.25 meters away from the charge. So the problem asks you to find the charge, and it also asks you what is the electric field 10 meters away. So you're going to multiply the distance away by 40. So let's see what that does. Of course, you have the electrostatic constant, also known as the Coulomb's constant. Hopefully you remember that. And you have this equation for electric field, which is kq over r squared. And that's an important thing that happens, that over r squared. So you don't even need, you just need one formula to solve it for q, because that's what we're being asked for, is the charge on this point charge. And you plug in what you know to find the charge. You know that at 0.25 meters away, it's 10,000 newtons per coulomb, which is a pretty strong electric field. And then you divide it by K. So you get the charge, which is 6.94 times 10 to the negative 8th coulombs. Remember, coulomb is a pretty big unit, right? So that's a decent sized charge. But then it says, okay, what happens if you actually move 10 meters away and measure it? Still have the same charge, right? So it's kq over r squared still. And then you put the 10 down here in the denominator. And you go from a 10,000 Newton per Coulomb electric field to a 6.25 Newton per Coulomb electric field. And let me tell you how you could have done that without even doing any of this. You are multiplying the denominator by 40, and in the denominator, the radius is squared. So you'll divide this by 1,600. And that's how I checked my answer. I was like, let me make sure I plugged everything into the calculator right. Divide this by 1,600, and sure enough, you get 6.25 newtons per coulomb. So those are your solutions. And it tells you something, that the electric field falls off with that inverse square law. So when you move further away, it gets a lot smaller. So hopefully that'll help you while you're thinking about electric field.